Good afternoon, good morning, and good evening, everyone. Thank you for joining us today for Japan's partner session, Future Networks and Standardization for Beyond 5G. My name is Memiko Otsuki from the Ministry of Internal Affairs and Communications, Japan. It's my pleasure to moderate this session. So everyone would agree that the advanced network like 5G and its standardization effort are quite important. And this session will discuss the expectations and challenges for the introduction of the 5G and beyond. So we have three distinguished speakers for this topic, including Mr. Onoe from NTT Japan, Mr. Eric Ekden from Ericsson, and Mr. Durga Malari from Qualcomm. Following their presentation, we will introduce Mr. Takahashi from a company who is the winner of the ITU Certificate of Recognition at the Entrepreneurs Expo in 2020. So before starting the presentation, let me do some housekeeping. I would like to inform the audience who are participating in this session that there are no Q&A sessions during this discussion. So if you have any questions to the panelists, please send your questions to the address displayed on the screen now, which is itudw@ml.soumu.go.jp. So, I would like to start this session by inviting our State Minister, Mr. Shintani, for his remarks. So please welcome His Excellency, Mr. Masayoshi Shintani.
Your Excellencies, distinguished guests, ladies and gentlemen, I am honored to announce the opening of this Japan Partner Session for ITU Digital World 2021. And I would like to express my sincere appreciation to the ITU, the distinguished speakers, and all participants and stakeholders present here today. The expectations for ICT to address social issues are increasing, and the technical issues for international standardization are becoming more diverse and sophisticated. A lot of countries have just started commercial fifth generation mobile communications systems. However, we already need a standard strategy of new technologies for the beyond 5G era. This is expected to ensure the interoperability and quality of products and services by encouraging the participation of more players, which will lead to reducing the costs of various services. Technologies in the beyond 5G era also have the potential to achieve resilient and sustainable societies and economies. Japan has formulated a beyond 5G strategy with the aim of realizing an inclusive, sustainable, and dependable data-driven society. This roadmap is based on three basic policies entitled Global First, ecosystem-driven innovation, and concentrate resources. It was established for the government, private sector, and other stakeholders to work together to realize a beyond 5G ready environment and international collaboration. The government of Japan will work on international standardization activities in cooperation with the private sectors as well as local and international governments. We have invited various speakers from different fields, including 2 global manufacturers, 1 large network operator, and 1 startup company. I believe They will share good practices and interesting insights with us today. I would also like to mention about our contribution to ITU activities. As one of the founding members of ITU, Japan has provided technical, physical, and financial support for a long time. In order to share our experiences of the Beyond 5G roadmap with other member countries, Japan has participated in the Connect to Recover initiative in collaboration with its Telecommunication Development Bureau and other members to strengthen the digital infrastructure and ecosystems of beneficiary countries. Also, a total of 19 study groups are currently active in the 3 sectors of ITU, and the chairpersons and vice chairpersons from our country have been leading discussions in more than half of these study groups. We believe that such human resource contributions will continue to be important as part of Japan's role to play. Mr. Onoe is going to make an opening keynote presentation in this session, which will make his rich experience and knowledge on international standardization activities very clear. Everyone, please welcome Mr. Onoe from NTT Japan. Thank you for your attention. Mr. Onoe, the floor is yours. Thank you.
Hi, I am Seizo Onoe of NTT. Today, I'd like to discuss the market expectations for new generation and worldwide penetration status to see the future. I start with the market expectation for 4G. The term 4G was not so popular in the early stage of standardization. Once LTE was noted in 2008, however, next year, 3G evolution HSPA Plus was in the spotlight just before the LTE launch. But after LTE launch, LTE deployment was very quick, as shown in this slide. This slide shows the number of operators that launched 3G and LTE by year from the respective launch year. LTE was much quicker than 3G and very successful technology in commercial deployment. 5G is slightly different. 5G boom came before its launch. When 5G boom came, do you remember? It's 2015. I measured this by counting the number of buzzwords in daily news headlines of Mobile World Congress. This boom lasts until today, and now it's still around the peak of the inflated expectation. At the early stage of this boom, around 2015 or 2016, I felt a bit irritated with the 5G boom because everyone talked about 5G, even though it had nothing to do with 5G. I didn't like that. So I created this slide to make people calm down. This slide was very well received by the audience. Yeah, just what I want to say here is that the number of opportunities of 5G presentation shows a high level of expectations for 5G. This expectation has started involving other vertical sectors. 5G has attracted the interest from various verticals, creating cross-industry collaboration. and now and new business opportunities. It was a good thing. So I changed the message of this slide. Let's get on the 5G bandwagon. Actually, the cross-industry collaboration will be the key to success for 5G. Today, most people believe that many activities are now ongoing. And 6G discussions have already begun, even earlier timing than 5G case. I hope we can discuss standards for sustainable further evolution rather than the rushing the generation number in increment for 6G and after. Then next, I'd like to discuss the technology penetration. I was on the panel at the WTIS symposium a few years ago, 6 years ago. I remember an impressive question from someone from African country. I don't remember the exact country name. I'm sorry about that. But what he said is that they need broadband, not just a connection, but they need a broadband. How to get it? That's his question or statement. It was nothing new in ITU and a very common goal in ITU, but impressive for me since I had focused on technology evolution mainly until then. It was tough to answer only from technological point of view. My thinking was, as the technology matures, costs will come down, and adoption or penetration will proceed. But here we face a problem. The issue is the timing difference. Then how different are the timings by region? I discuss this next. I was invited to speak in Durban, South Africa 3 years ago. This is the number 19 of the 5G bandwagon series. Yeah, in the speech, I show the one slide. This the technology penetration rate for each generation by region. Here I added African market data to speak in Durban. Today I can show you the more updated version, adding 3 years more data and 5G. A bit busy slide, so I can show you just the 3G only, 4G only, 3G, 4G. Some changes in the order, but we don't see so big difference in the width. Width means the difference in introduction timing, penetration timing. I summarized the trend 3 years ago and put my guessing about 5G. 5G is just started, so still uncertain, but I hope the quick regions or quick countries increases as the generation goes up. Much simply, I can say 5G deployment is even quicker than 4G, as shown in this slide. The spread of new generation technology will help the spread of broadband. Next, I'd like to discuss the meaning of generational change or generation upgrade. Okay. People tend to believe that new generation technology makes a big leap at the introduction time. However, the reality is different. This is an example of the data rate enhancement. We should understand that the value of a new generation introduction is ensuring the continuous evolution after its introduction, not a performance leap at the introduction moment. The newest generation everywhere might not be a must for the broadband everywhere worldwide. The reliability is more important than the technology name or the generation number. We see some positive factors in recent generations. And one is the evolutionary approaches was taken. At least in radio technology, and progress of the softwareization may help rapid spread of new network features. The generation upgrade may not be major means for broadband everywhere, but these positive factors may back its realization. Okay, I talked the level of expectations for 5G and the resulting cross-industry collaboration, and discussed the penetration of new generation. And the last point, third point, is just my personal view. Looking at the, I feel recently looking at the rushing increase in generation number, I feel the need for the long-term vision of sustainable evolution with the view to worldwide penetration. And that's all my presentation. Thank you. With this picture, NTT Docomo invited the speakers to the first match of Rugby World Cup 2019. The day was the launch day of Docomo's 5G pre-commercial service. This is not the reason why they are keynote speakers, but next speaker is the gentleman in the center. In the center, Eric Ekden-san, Ericsson Chief Technology Officer. Please welcome Ekden-san. Ekden-san, floor is yours.
Thank you so much, Onoe-san, and hello, everyone. I think we have now seen a lot of familiar faces, and at least for us in the industry, and also a very good description of how the mobile industry has developed over 5 generations. I will share some of the learnings from the 5G era, which we are in right now, what we see beyond 5G, and also how this could be a road, a long-term road to 6G. And this really starts by looking at where we are today. So if you go to the next slide, we have a faster uptake of 5G around the world, as Onoe-san said, than 4G and previous generations. We have already around 179 5G networks. We have more than 900 5G smartphones launched. By the end of this year, we will have 580 subscriptions. And 5 years into the future, we will have as much as 8.8 billion GDP subscriptions. 5G will be a big part of that, 3.5 billion. And also the growth in terms of wide area or cellular IoT subscriptions is phenomenal, reaching some 5.4 billion in only 5 years' time. So another 5 years out, by 2030, we actually see that the sector collaboration that Onoe-san also talked about is already happening now, but it will be much more dominant 10 years from now, where the 3GPP technologies, 5G, and many other technologies will be a common infrastructure for innovation in the enterprise space. So $700 billion of 5G-enabled operator business-to-business revenues. The manufacturing and smart manufacturing, just as one example, is going through a tremendous transformation now from predominantly unconnected or fixed connected equipment to a wireless connected world. So some 4.7 billion wireless connections in smart manufacturing by 2030. And that's, of course, an enormous change, business models and the technology, but it is a great opportunity for the industry to capture. And what I want to say with this is that the momentum and the global scale of international standards has really paved the way in the past and also in the coming 5 to 10 years. In fact, the innovation power of this ecosystem and this industry in things like standards, in ITU, 3GPP, and so forth, has really enabled this fantastic value creation. So if you go to the next slide. We are right now going through a shift from more integrated networks to horizontal networks, basically taking the journey towards cloud native across core networks, orchestration across radio networks. We introduce edge compute to be able to move workloads further out in the infrastructure to lower the latency and also increase the user experience. But this also means that we have to keep up with the bandwidth, the higher frequencies, the orchestration end-to-end. We need technologies such as carrier aggregation. We need all of that to bring latency down and to be able to serve the new services that are coming now, both in the consumer space as well as in the enterprise space. And one of the key tools in this journey is really to provide better performance, higher guarantees through network slicing. This technology has been in the making a long time and now is being rolled out commercially, deployed in radio networks, core networks, transport networks, orchestration layer, and also into devices such as the Ericsson 5G wireless router that is also implementing network slicing. So the high performance part is becoming a key feature of 5G. If you move to the next slide, you can see that this technology journey actually builds on unique hardware. The first slide I showed, that was Ericsson's unique Ericsson silicon that we are deploying around the world as a way to get acceleration performance, lower power consumption, higher efficiency, more sustainable, but also increased performance versus more generic solutions. So accelerators is a key part of this. It is a cloud transformation, and now the Ericsson Cloud RAN is one piece in that piece puzzle where we are basically cloudifying the whole stack. And open source for efficiency is one piece. But it deserves to be said that this is a transformation for our industry also when it comes to continuous development, continuous integration into networks, or CI/CD. And this comes with much higher efficiency, faster turnaround, software features that can be upgraded and updated on an hourly basis rather than on a month or yearly basis. To deal with the complexity, the integrated AI is a part of that. Automation is where we are starting, but we will add much more over the coming 5 to 10 years when it comes to integrated AI. And this really paves the way for the internet evolution, or perhaps even revolution, when it comes to the distributed infrastructure with capabilities all the way out in the edges and also guaranteeing performance that was mentioned in the introduction of this session about resiliency and robustness in critical infrastructure. So just showing one example of what we are already doing today. If you go to the next slide, this is really about digital twin technologies and having a digital representation of, in this case, a base station based on a point cloud animation here. This is really where we are today. 5G enables this through the bandwidth and through the latency. And in this case, drones that are then 5G enabled help us to keep track of inventory, make sure that we do the right upgrades in field, but also, of course, being able to take on new challenges beyond just the base station. As you can see, this could be used for all kinds of maintenance and surveillance applications. So that's where we are today, 5G. If we then switch gear a little bit more to the future and take a look at the next slide, we are starting to see new use case scenarios that are enabled already by 5G, but that actually will be further enhanced when we get even higher bandwidth, lower latency, even more robustness. So one area is the Internet of Senses. This is really where we are taking the very early experiences from haptic feedback and things that we're doing now in the consumer and gaming space into a full-fledged fabric that supports smell and taste, and of course everything that comes in a multi-sensory communication environment. It's also about all these devices that are being connected, the intelligent machines that are connected, driving needs for interoperability, but also much more performance out of the network infrastructure. It's also very much about the digital twins that I showed in the previous examples, digital and physical coming together in a programmable world. And this is where we see that early examples like in our own smart manufacturing and what we do in ports like the Port of Livorno in Rotterdam, really paves the way for creating full digital representations based on networking technologies, 5G and beyond 5G. And then last but certainly not least in this set of use cases, the connected sustainable world, where we have an opportunity to use 5G and digital technologies to reduce emissions significantly by 2030. In fact, our estimates indicate that more than 15% of the global emissions can be reduced using latest ICT technologies, 5G in particular. And this is, of course, a transformation change or transformation enabler, but it's also the necessary foundation for much of the other transformations that needs to be done towards a sustainable world. So we really see that as an industry, we can do so much more, of course, taking care of the emissions and the situation in our own sector, but really supporting automotive transformations, logistics transformations, all kinds of travel, but everything that goes into retail, what we see in the financial sector, what we see in the health sector, all of these sectors will tremendously benefit from 5G and digital technologies. So just let's take a sneak peek of the future when it comes to the Internet of Senses. So one of these use case scenarios in the future. So if you want to shift to the next one and play the video.
Okay, let's see. A dinner party.
Food selector.
An Arabian Nights.
Playing music. Main course suggestion.
Looking good.
Personal table setting. Changing tiles to theme.
This is better.
Changing personal table setting. Checking calendar. Sending invite. Victor accepting invite. Emily accepting invite. Thomas accepting invite. Composing message. Surprise Anna at the party. Ingredients from digital store. Tasting mode.
Nice.
Emily and Victor are vegans.
Okay, maybe a plant-based stew?
Alternative main course. Vegan stew. Ordering vegan stew. Your friends are here.
Come on, you guys.
Perfect dinner location selected.
Okay, so given our mostly around the world limitations with work from home and still in many cases working through the pandemic, this is of course something that would be great already today. Anyway, if you go to the next one, just indicating that we are really in the early phase now of thinking around what does the generation beyond 5G need to cater for? What are the needed capabilities? And we look at that in a number of buckets. One is really the capabilities that are more traditional, the data rates, the latency, positioning, coverage, and so forth. Energy efficiency being maybe one of the more important basic characteristics, but also looking at more extreme capabilities, extending into new dimensions where the robustness, resiliency, service availability, service versatility, hosting distributed applications, extreme devices, sensing, and also further deployment flexibility will be more important in the generation to come. So on next slide, just pointing out then that I already mentioned that the AI piece, sorry, one back. If we just look at where we are now in the automation journey, the coming 5 to 10 years will really be about fusion of what we do on the networking side and what we do on the data side with AI and 5G, AI and 6G coming together. And this is really where a cognitive network, a network that is driven by intent, a network that is not only having the brain power, but also leveraging all the operational data and the data infrastructure really comes together. And I think we're starting to see fantastic gains. So there is an efficiency aspect of this. There's a higher performance aspect that we already start to see. But of course, this is also a big change in terms of how other industries can leverage the network platform, the innovation platform that we are now creating with 5G and will evolve into 6G. So if you look at the last slide here, how we look at the industry commitment to the long-term timelines, I already said that the industry has shown that innovation comes from open standardization. Innovation comes from continuously challenging ourselves and building new technology into standards. But if we take a look at what's already happening in ITU with the vision activities that will lead to the report in 2023, if we look at what we have learned in terms of previous generations, how long it takes to build the foundation, the research, the activities in early requirement setting, all the way into standardization and commercialization, we are looking at a 10-year timeline. So in this case, the ITU process and towards 2030. But we also realize that there's much work to be done in the meantime here when it comes to 5G Advanced, Release 18 in 3GPP as a starting point, and many more things to come in the future years. It has worked really well to collaborate across international standardization bodies, open standardization bodies that can really get the scale that the industry has benefited from. And we see this as a great example of how we can, of course, leverage what we've already done, but continue to evolve and drive novelty into also the standardization process. So with that, I'd like to shift to the last slide, which is really just wrapping it up and noting that we may be, back to Noah's point, in the early phase of 5G, but we see that the uptake and the interest among not only the consumer and the device side, but also the enterprises is truly paving the way. In fact, fixed wireless access or residential access based on 5G is another great example, which is happening now around the world. More than 160 service providers are already offering commercial fixed wireless access services. And if you then look at the uptake and the interest among consumers, really hungry for better user experience, but also connected to new experience on new device form factors, application services that come together with 5G, is really becoming a success in the early markets. But it wouldn't come without the international collaboration and standardization that 3GPP and ITU really stands for. So that's why we are very certain now that we have you could say a starting point that is the best possible, also stretching into beyond 5G and 6G. And this really comes from realizations of timelines for building new silicon, high performance, low energy consumption, and high sustainability. It comes from the fundamental technology that needs to mature across the infrastructure, but it also comes from learnings on new and demanding use cases. And this really points to what I said about the Internet of Senses, or things that really go beyond our current capabilities and stretching our imagination into what could be possible by, let's say, 2030. So thanks for the opportunity to share some thoughts about the upcoming years, including the standardization. So back to you, Ono-san.
Thank you very much, Mr. Ekiden, for your insightful and entertaining presentation. So I would like to introduce our next speaker, Mr. Durga Maladi, Senior Vice President and General Manager of 5G Mobile Broadband and Infrastructure of Qualcomm Technologies. Please welcome Mr. Maladi.
Hello, I'm Durga Maladi, Senior Vice President and General Manager of 5G Mobile Broadband and RAN for Qualcomm Technologies. It's a pleasure to be participating in this year's ITU Digital World event. I wish we could all be together in person. I know that many continue to deal with the impact of the pandemic, and I sincerely hope we can overcome it soon. Today it is clear that connectivity is essential for everyone. It's essential for work, for healthcare, for education, and so much more. Connectivity is also essential for a future of strong economic growth and a more resilient society. Given the significant increase in data traffic we've witnessed over the past 18 months, the pandemic has reinforced the need for 5G to provide the performance and capacity necessary to support massive data growth beyond the next decade. The 5G opportunity is part of a bigger global trend where everyone and everything can be intelligently connected. It's being driven by the convergence of ultra-fast 5G connectivity, high performance, low power computing, and on-device AI technologies, along with massive growth in the cloud. With 5G, devices can be connected to the cloud 100% of the time, delivering new experiences with ever-increasing amounts of content, processing power, and storage. This is fueling the emergence of the connected intelligence edge where billions of smart connected devices will be deployed and have a significant impact across industries. The combination of 5G, AI, and the cloud will serve as a powerful catalyst for innovation and economic growth around the globe. Over the course of the pandemic, we've watched industries and enterprises accelerate their digital transformation efforts. And while wireless has played an important role to date, 5G is integral to the digital future, enabling new business models, new services, and new revenue streams. 5G and other mobile technologies that unlock these possibilities were proven and scaled by the mobile industry and are now poised to fuel progress and innovation across virtually every other industry. And the economic impact of 5G will be significant. According to analyst projections, 5G will enable more than $13 trillion in global sales activity in 2035 across a range of segments, including manufacturing, logistics, healthcare, education, entertainment, and more. By investing in 5G, governments can create significant opportunities for domestic innovation and economic growth. But in order to take full advantage of 5G and enable it across networks, industries, and the home, we need next-generation infrastructure that is diverse, scalable, secure, and adaptable. It also needs to provide high performance and power efficiency both indoors and outdoors, and support public and private networks. These needs are driving a shift to a more virtualized, modular, and interoperable cellular infrastructure, or Infrastructure 2.0. The flexibility and scalability of virtualized and modular radio access networks, or Open RAN, will accelerate innovation in cellular infrastructure, help lower costs, and enable a software upgradable network architecture. This modern approach to networks replaces purpose-built proprietary radio access hardware with software-defined technology that runs in off-the-shelf computer servers and routers, making the radio access network more flexible, scalable, and cost-effective. Open RAN enables a standards-based and interoperable marketplace that's more open, robust, innovative, and competitive. As a result, the modern network is poised to foster greater innovation in public and private networks from small, large, and startup companies. And the commercialization of virtualized and open networks is underway. For instance, Rakuten is rolling out a virtualized network in Japan, and other major operators have established trials in the US, Europe, and other regions. Qualcomm Technologies also joined forces with NTT Docomo and a dozen other ecosystem leaders on the creation of the 5G Open RAN ecosystem to accelerate Open RAN proliferation globally. And last year, the launch of new Qualcomm 5G RAN platforms with support for Open RAN was supported by 15 leading global operators, another proof of the momentum behind the new approach for modern 5G networks. 5G can do a lot for people, for industries, and for economic growth, but it's most impactful when we take full advantage of its capabilities. This includes utilizing all types of spectrum, which is what 5G is built to do. Existing lower bands in sub-6 GHz provide wide area coverage for service continuity. 5G in sub-6 GHz mid-bands provides additional capacity and bandwidth. And 5G millimeter wave provides multi-gigabit data rates, massive capacity, and intrinsically low latency for dense urban spots, fixed wireless access, enterprise, and industrial applications at a lower cost per bit. It will be a key part of many new use cases, such as 8K video editing in the cloud, virtual learning in collaborative multidimensional spaces, and 4K video conferencing, as well as supporting capacity needs for crowded venues like transit hubs, shopping malls, and stadiums. Millimeter wave is already going global with commercial networks in Italy, Singapore, Australia, and the US, with more to come. In Japan, all mobile network operators now offer commercial 5G millimeter wave. In less than 6 months, the number of 5G millimeter wave base stations in Japan increased threefold, from around 2,300 in September 2020 to almost 8,100 in March of this year, representing nearly a 45% of total 5G millimeter wave base stations. It's important for operators to know that millimeter wave is not a competing priority, but rather a complementary aspect of network strategy of mobile operators. And millimeter wave deployments are cost effective, with analyst data revealing that in places where capacity needs are high, a system with millimeter wave and mid-band spectrum has a lower total cost of ownership than mid-band alone, with savings up to 35%. 5G millimeter wave also represents a significant opportunity for further economic growth. In Europe, where the UK and nearly half the countries in the European Union have allocated 5G millimeter wave spectrum or have plans to do so, analysts estimate that 5G millimeter wave deployments will generate a cumulative GDP uplift of more than 140 billion euros through 2040 across 30 European countries. And in China, where we are working closely with ecosystem members to showcase 5G millimeter wave at the 2022 Winter Olympics in Beijing, the economic benefit arising from the use of millimeter wave is expected to reach over $100 billion by 2034, based on data from the GSMA. In terms of performance, 5G millimeter wave speeds are amazing, especially on Snapdragon. Data from Ookla revealed that our Snapdragon 5G modem RF system delivers millimeter wave speeds that are 16 times faster than 5G sub 6 GHz, and an incredible 38 times faster than LTE. As a global leader in millimeter wave, Qualcomm has developed a number of programs that we will be launching over the upcoming months to help accelerate its adoption. In addition to their impact on experiences and industries, 5G millimeter wave will also serve as a powerful tool for addressing important societal issues. An issue that has become more pronounced during the pandemic is the broadband gap. It's impacted education, small businesses, and more, especially in rural and lower income communities. A 5G millimeter wave fixed wireless access will help bridge high-speed connectivity to schools, libraries, and homes that lack access to broadband services. It provides a cost-effective last-mile technology for urban, suburban, and rural areas, helping to close the digital divide and broadband access gap, and extend the benefits of connected economic growth to underserved and new communities. It should be no surprise that 5G millimeter wave fixed wireless provides robust performance. During a recent collaboration with US Cellular and Nokia, we achieved a 1 gigabits per second fixed wireless data connection at a distance of more than 6 miles, a world record. And just as important, 5G millimeter wave fixed wireless is cost effective. Based on industry research, a combination of 5G millimeter wave and sub-6 spectrum allows operators in rural America to provide fixed internet access at a total cost savings of 40% compared to just using sub-6 by itself. Qualcomm is seeing significant growth with fixed wireless access in the US, driven in part by our industry-leading portfolio of 5G fixed wireless solutions. While we are busy leading the commercialization of 5G across regions, we continue to invest significantly in R&D to drive the evolution of our 5G roadmap, with upcoming releases of new 5G specifications to help realize the full potential of 5G. Building upon the 5G technology foundation established today, new 5G releases will bring enhanced capabilities and features that will enable entirely new industries, support next-generation services and business models, and create exciting new use cases and experiences. Some of the 5G expansion areas we're really excited about include enhanced 5G IoT support with ultra-reliable, low-latency connectivity for industrial use cases, as well as a scaled-down version of the 5G NR standard called NR Lite for low-complexity devices such as sensors and wearables. Improved end-to-end 5G system performance and optimizations for 5G augmented reality experiences, including a new edge processing framework, and the ability of 5G to operate using satellites. The possibilities with the 5G roadmap are truly limitless. We're also working on key longer-term research vectors that will eventually lead the path to 6G, including more scalable network architecture with cloud-to-device disaggregation and virtualization, new radio designs that can provide differentiated performance and efficiency, communications resiliency that adopts a secure by design approach, AI and wireless machine learning enabling data-driven wireless design approaches, and dynamic and adaptive coordinated spectrum sharing, and even higher spectrum bands. The vision for 6G is starting to take shape. However, we are still several years away from formalizing 6G, defining system design objectives, and driving meaningful implementation proposals. Qualcomm is actively participating in 6G discussions with academia and governments, as well as supporting research centers at universities. We are still early in the commercialization of 5G, and there is a long road ahead to proliferate it globally and expand 5G to new use cases and industries. At the same time, we are working closely with ecosystem leaders to pave the path to the 6G future. As the global leader in 5G, Qualcomm continues to set the pace of innovation in wireless. But from our ability to partner with companies across industries to drive innovation, we remain committed to collaborating with and enabling the 5G ecosystem, providing our partners in Asia and around the world with the most comprehensive technologies and system-based solutions that reduce complexity and help them to innovate and grow globally in the 5G era. I look forward to innovating with you to shape the 5G future. Thank you, and enjoy the rest of the conference.
Thank you very much, Mr. Maladi, for your presentation. So far, we have heard 3 distinguished presentations regarding the 5G and beyond. The next presentation is not directly related to the 5G, but we would like to introduce our next speaker, Mr. Takahashi, who will be representing Japanese innovative startups. He is a CEO of a company called A Company, and its cutting-edge product won the ITU Certificate of Recognition at the Entrepreneurs Expo in Japan this year. So please welcome Mr. Takahashi, a CEO of A Company. Mr. Takahashi, over to you.
Hi everyone, I'm Yosuke Takahashi from A Company. I'm the founder and CEO. I would like to introduce secure computing and our product Quick MPC. A Company is a startup. We are working on R&D and the social implementation of secure computing technology. Our mission is to solve the trade-off between data utilization and data privacy protection. I'm going to introduce my company briefly. I founded a company in 2018, and this is the 4th year around. Our business has been selected as Gestar Central by the Japanese government. We have received their intensive support to aim for global success. We are also a university-launched startup certified by Nagoya University and Nagoya Institute of Technology. Next, I'm going to explain our business background. Now, Japan is far behind to utilize digital data compared to the fast-growing US and European IT companies. To compete against this, the Japanese government emphasized the importance of data linkage and distribution in the future. It is also mentioned in Society 5.0, which shows what the next generation of data utilization should be. On the other hand, the problem of privacy breaches and data leakage became obvious too. Privacy breaches and data leakage would cause great damage or impact. It also becomes the loss of the brand image of the company or organization. In many cases, it will spread to related parties such as business partners and customers. Especially when handling privacy data, it is also a social responsibility for company and organization to protect it. As a result, we have difficulty taking advantage of data utilization. In other words, it is a trade-off between data utilization and data privacy protection. We can solve this problem by using secure computing. Our secure computing product, Quick MPC, is a unique software developed by us. Quick MPC can protect data and privacy. Also, it enables data utilization more and more. Secure computing is a generic term for technologies that process data while keeping it encrypted. In other words, it is a technology that allows computation to be performed while being encrypted. In a plus way, it is unable to protect data while utilizing. On the other hand, secure computing is expected to be a very powerful next generation cryptography because it enables data protection even if while utilizing. Again, I will introduce our unique product, Quick MPC. We are working on secure computing with secure multi-part computation. Quick MPC is software for building a secure multi-part computation system. It is complicated to build a secure computing system because it required a high degree of expertise and technical ability. Quick MPC makes it possible to build it easily by using our software. Secure computing can solve various problems when analyzing a combination of multiple data. The current issue of data linkage between multiple companies is an example. They want the analysis results of data linkage, but don't want their own data to be seen by other companies. Since it is difficult to provide the raw data to the outside as it is, the data will be anonymized before providing. In this case, there is a problem that the accuracy of the data is reduced no matter what. However, secure computing can solve this problem in such a thing. Now I will explain how to perform computation processing while keeping data secret. We use a way called the secret sharing scheme. For confidential information, the data is divided into several pieces of information called shares. Data confidentiality is ensured by physically distributing these shares across multiple servers. Then a process called multi-party computation is executed on each distributed server. It generates shares of analysis results from each server. The analysis results are restored by collecting these shares. I will introduce a case of computing the average annual income of 3 people, Mr. X, Y, and Z. Secure computing is used to compute while hiding their annual income information. Well, first, by secret sharing scheme, it randomly divided each one's annual income information into shares. For example, 200, 300, 500 in the case of Mr. X. These shares are stored on multi-servers. Look at the server on the top for Mr. X. You cannot guess 1,000 or Mr. X's annual income from the random number of 200. The same is true for Mr. Y and Mr. Z. Thus, this secret information, in this case, each annual income, cannot be revealed at all from the server side. Next, by this multi-party computation, take the average value of the set of shares. Then we get the number 500, 700, 800, and correct them. We can get 2,000. As a result, while keeping the data secret, we are able to obtain a value of 2,000, which is the average annual income. Since this example was an average process, the computation was very simple. However, for example, when multiplying the secret information of Mr. X and Mr. Y, it is not possible to compute by simply multiplying the shards. There will be a need to perform more complicated processing. In this way, we can perform statistical analysis and machine learning by designing processes that's equivalent to the same value as raw data in secure computing. At our company, we are working with partner companies. We are working to expand our business by achieving the secure collection and analysis of various data through secure computing. For example, one company wants to use the big marketing data of the other companies. We can integrate and analyze both data on secure computing. By doing so, we can build a platform that enables analysis of prospective customers and analysis of new business targets while protecting the privacy of users. Also, until now, medical treatment data have not been shared outside because it is a security issue and confidential information of the hospital itself. We are now working with a universal hospital. We collect their medical treatment data while keeping it secret by secure computing and utilize them for optimizing the management resource of the hospital. Finally, I would like to introduce the strengths of our company. By way of introduction, there are barriers in 3 areas to make a social implementation of secure multi-party computation. They are in areas of technology, business development, and legal. For example, technically, there is no practical open source software. Also, the implementation of secure multi-party computation requires multiple highly specialized technology stacks. In addition, in secure multi-party computation, the target is privacy data. So it is necessary to make full use of legal understanding and business development capabilities. The strength of a company is that we have these 3 parts together. The first one is the technical implementation ability of secure computing. The second is the business ability to drive commercialization speedy. Finally, we also have a legal team. They have knowledge of law and regulation such as the Japanese Personal Information Protection Law and use GDPR. These 3 teams are very important for both privacy protection and data utilization. In other words, a company is a startup with strengths in developing privacy protection solutions. If you have problem with privacy data protection and data utilization, do let us know. Thank you very much.
Thank you very much, Mr. Takahashi, for your presentation. So now we finished all the presentations, and I would like to give you a brief summary of this session. So listening to the views of 3 distinguished speakers, this session discussed the expectations and challenges of future networks and standardization for beyond 5G from a global and multi-stakeholder perspective. So Mr. Onoe's presentation gave us a great insights of market side expectations for and value of new generation networks. And from the presentations of Mr. Ekden and Mr. Maladi, we could get some interesting pictures and idea how the future of digital technologies and the future of our life and society look like. And also we learned what's needed to realize such future. So we also had a chance to know the interesting and innovative technology that one of our startups created and it can be a good example how we can utilize these technologies on the future advanced networks. So that's for wrapping up. If you wish to ask any questions to the panelists of this session, please send your questions to the email address displayed on the screen, which is itudwml@soumu.go.jp. So now I would like to conclude this partner session and wish to thank all the speakers for their excellent and extensive insights that were shared with us. I would also like to thank ITU for their support to hold this session. And of course, I would like to thank all the audience who participated in this session. So thank you again, and I hope you enjoy the rest of other upcoming sessions of ITU Digital World.